So welcome to Working with Microservices in Go. And in this course, we're going to learn how to build scalable, resilient, distributed applications. And we'll write all of those microservices in Go. So what are we going to be doing in this course? So a lot of people have experience writing what are called monolithic applications. In other words, all of your business logic, your connection to the database, your authentication, everything is built into a single application. And that works really well and is useful for a lot of cases. But what we're going to be doing in this course is working on what are sometimes called distributed applications. In other words, instead of just having one big monolith, you have many smaller applications that do one thing and do it well. And we call this the Unix philosophy. In Unix, you have simple commands that only do one thing, and they do that one thing all the time, exactly as you would expect, without any problems whatsoever. So those are called microservices. Now, a monolithic application, as I said, is one piece of software, one compiled binary or one application written in Go or Python or whatever it may be, where all the logic exists in one place. So on the left-hand side, you have a user on a computer who accesses your application, and that might read to and write from a Postgres database or a Redis cache or something like that. But whatever the case may be, everything exists in one code base and compiles to one binary if you're using a compiled language like Go. So here, if we have user authentication, you hit one application and you authenticate the user. That might call the database, verify username and password, whatever the case may be. If you need to send email, that same application that authenticates users also sends out email, and it handles logging, and it handles absolutely every aspect of the application. And in a lot of cases, as I said, this is absolutely fine. But in the modern world, and this took me a long time to draw this graphic, and there are arrows all over the place, and there actually could be more arrows, but in modern applications that need to scale, you have the user at the very top of the screen, and that user hits one or more front ends, each of which is its own application. So if I'm going to hit, say, the one labeled front, that's a very small application. And all that does is serve up web pages. Nothing else. It just serves web pages. And then if you need to send email, that front-end microservice contacts the mail microservice. And all that does is send mail. And it knows nothing about the front end other than how to receive a request from it. And it sends mail out. And if the user needs to authenticate, well, the front-end microservice goes way over to the left-hand side of the screen and says, here's a username and password. Is this valid? And the authentication service, all it knows is about the username and password and nothing else. And it sends back false if the user supplied the wrong username and password, or it sends back true and whatever information is required, say username, email address, whether or not that user's active, it sends that back to the front end. In other words, all of these microservices are loosely coupled. And if I want to change one, I don't have to change the entire application as I would in a monolith. I just change an individual microservice. So another thing to note is that whereas in that monolithic application, my web app has one database, here, each microservice might have its own database. So in this example, the authentication database is reading to and writing from Postgres. The logging application is reading to and writing from Mongo. The AMQP, which is the Advanced Message Queuing Protocol, it talks to RabbitMQ. So each microservice might have its own database. And that's a very different approach. Now, there's a lot of advantages to this. And really, when you think it through, a distributed application consisting of microservices is really nothing more than taking a monolith and breaking up packages or individual functions in that monolith into completely separate programs. Now, how do these microservices talk to each other? Far and away the most common and the easiest is to use a standard JSON REST API. So each microservice reads and writes JSON when it talks to the front end or authentication or mail, whatever it may be. But there are other approaches as well. Remote procedure calls, for example, which are much faster than JSON REST, and gRPC, which is even faster than RPC in many cases. Not in all cases, but in many cases. And you can also talk to the individual microservices by pushing something into a queue, like RabbitMQ, which I'll be talking about extensively in this course. So that messaging queue actually receives messages, and then something consumes them, and then takes an individual action based upon whatever message it received. And we'll be doing all of these approaches in this course. Advantages to microservices. Well, it's much easier to scale a microservice. If you have each service in its own Docker image, for example, you can put this into a Kubernetes cluster and have as many instances of an individual microservice as you need. And that makes it really easy to scale as you get more traffic to your application. It's also easier to maintain because microservices are much simpler. It's not one large complex monolith. Instead, you have small services, small programs that are easy to maintain because they just do one thing. The drawback, of course, is that it can be harder to write microservices, but not that much harder, as you'll see as we go on in this course. Now, what are we going to build? We're going to build a front-end web application, a very simple web application that just serves up a few web pages, and that will connect to 5 different microservices. We'll have a broker, which is an optional single point of entry into the microservice, and that's what we'll start with. So the broker will receive requests from the front end and then fire off requests and consume the responses from different microservices. We'll have an authentication microservice where we log users in, and that will have a Postgres database behind it. We'll have a logging microservice, which is connected to MongoDB, and that will log events from all of the other microservices. We'll have mail that sends email with one or more specific templates. And we'll have a listener service that consumes messages from RabbitMQ and initiates a process based upon the message it receives. Okay? Now we'll communicate between microservices using the REST API with JSON, and that's what we'll start with. We'll also send and receive responses using RPC or remote procedure calls. And we'll also send and receive responses using gRPC, Google's remote procedure calls, which is kind of cool, but it does require some boilerplate code. We're going to do it anyway. And finally, we'll initiate and respond to events using the Advanced Message Queuing Protocol called AMQP. And we'll do that with RabbitMQ as the back end. Now let's have a look at what we're going to build. So this is a very simple web page with a few buttons at the top. And all this web page does, and this is our front end, is it connects to our various microservices that I have running in Docker. So for example, this one, test broker, if I click that, you can see that it starts the request, it ends the request, it tells me what I sent, which in this case is an empty post request, and it receives this information back from the broker. And the next one, test auth, it connects to the broker as well, but then the broker connects to the authentication microservice and tries to log someone in. And I gave it invalid credentials, so when I click this button, you can see that I'm posting an action of auth, simple JSON, and the data I'm posting is an email and a password. And I get back this message, error is true, and the message is invalid credentials. And I can do the same thing by clicking this, that will send an email message. And there it is. No error, message sent to you at there, and here's the actual content of the mail message. I can test the logging facility, and this again contacts the backend microservice, the logger service, through the broker, and it logs something to a Mongo database. So here I have no error and I logged some kind of data. And this one does the same thing, but instead of using RPC or remote procedure call, which is what this button did, this one does the same sort of thing using gRPC. So I click that and it logs the information. Now, this is just the beginning of the kinds of things we'll be doing, but this gives you a sense of how microservices will work. We have a whole lot of small programs that do one thing and do it well, and each communicates with the other using one of the various things at its disposal. So this will be a lot of fun. Let's get started.